Have you ever gazed up at the night sky, spotted that faint red dot called Mars, and wondered what if? What if humans were to leave Earth's cradle and build a second home on the red planet within our lifetime? Over the next few minutes, we'll explore a bold vision of how humanity might achieve a permanent settlement on Mars in just 25 years. It's a grand idea balancing rocket science, international politics, daring psychology, and even a dash of science fiction. But it all begins right now on Earth in the mid-2020s. Our journey starts in 2025. Space agencies worldwide, NASA, ESA, Roscosmos, CNSA, and private companies like SpaceX are already testing the technology that could make a Mars colony possible. According to NASA's Artemis program documents, returning humans to the moon by the late 2020s serves as a vital dress rehearsal for Mars. Astronauts practice in situ resource utilization, or ISRU, on the moon, extracting oxygen from lunar regolith, testing small nuclear reactors, and perfecting habitat modules. Parallel to this, SpaceX intensifies development of Starship, a massive, fully reusable rocket system meant to carry over 100 tons of cargo, or about 100 passengers, per flight. Its reusability, if proven at scale, slashes launch costs dramatically. Some analysts project that a fully reusable Starship might bring the cost of a Mars launch down to a fraction of current prices. By the late 2020s, robotic Pathfinder missions lay the groundwork on Mars itself. NASA's Perseverance rover already carried the MOXIE experiment, which successfully produced oxygen from Mars's carbon dioxide atmosphere. Now, bigger versions of MOXIE, along with small nuclear reactors tested under NASA's Kilopower project, are sent to Mars aboard uncrewed starships. These cargo flights deposit building supplies, habitat modules, rovers, and life support gear. Meanwhile, in Earth orbit, starships refuel from tankers to make the journey to Mars feasible. Here's the grand idea. Before a single human sets foot on the red planet, we want pressurized habitats waiting, power systems humming, and rovers already building out landing sites, all done by robots and automated systems. By 2030, we're on the verge of the first crewed mission, with the technology tested on the moon and validated by multiple cargo deliveries to Mars. The year is 2031. 2 starships, each carrying around 10 to 12 astronauts from NASA, ESA, SpaceX, and other partners, embark on a 6 to 7 month voyage to Mars. They land in a broad equatorial plain believed to harbor subsurface ice. Picture this moment. As the dust settles, these pioneers realize they are the first to stand on a planet that has never known human footsteps. They step into pre-deployed inflatable habitats. Outside, large solar panels sprawl across the dusty terrain, and a compact nuclear reactor quietly hums. Within weeks, an ISRU unit that arrived earlier begins extracting water from buried ice, then uses the Sabatier process to generate oxygen for breathing and methane for rocket fuel. It's not just a triumph of engineering. Psychologically, this might be humanity's greatest leap since the moon landing. Yet, living on Mars is no picnic. Communication with Earth involves up to a 20-minute delay each way, so these astronauts must make many decisions alone. They face dangerous radiation levels, sub-freezing temperatures, and a thin carbon dioxide atmosphere. Quoting NASA's data, the radiation on Mars averages around 0.67 millisieverts per day, almost 20 times what we get on Earth's surface. The colonists rely on thick walls of regolith piled over their habitats to block cosmic rays, and they have designated storm shelters in case of solar flares. Yet this risk is ever present. Some experts say just a few years of exposure could bring each settler close to NASA's current career radiation limits. Amid these dangers, the first arrivals build a small but permanent outpost. By 2033, a second wave of about 30 more settlers arrives, expanding the habitat into a rudimentary village. The settlers connect multiple modules, bury them for added shielding, and even erect a small greenhouse. Astronauts harvest the first fresh lettuce grown on Martian soil, once the perchlorates are removed, of course. With each new supply window, the outpost grows. From scientific research at the base's lab to daily chores like rover maintenance, these Mars pioneers discover that surviving together bonds them like a close-knit family. Conflict resolution protocols, similar to those tested in the Mars 500 simulation, help diffuse tension under the high stakes of Martian life. They have weekly communal dinners and watch pre-recorded films trying to keep spirits up. Though physically cut off from Earth, they're forging a new society, one improvised step at a time. And we'd love to involve you in that spirit of collective exploration. Let us know in the comments what part of Martian life fascinates you the most. Would you be excited to attend a weekly community dinner on another planet or try your hand at maintaining the biodome? Share your ideas, your questions, or even your concerns about living on the red planet. Your feedback shapes the conversations we have, and we can't wait to hear your thoughts. Fast forward to 2035. After nearly 4 years of continuous habitation, the colony, often referred to as Mars Base Alpha, is no longer just an outpost. Several shipments of heavy construction equipment have arrived. Crews now can produce steel, ceramics, and plastics from local resources. Under the guidance of NASA's and SpaceX's combined research, the colonists experiment with large 3D printers that sinter Martian regolith into building materials. They expand underground living spaces to shield themselves from radiation and dust storms. By 2037, the population has crossed 100. Children arrive with some families, and even the first pregnancy on Mars is rumored, though it's tightly monitored by medical teams worried about fetal development in 0.38 Earth gravity. These developments raise pointed questions about biology. Is Martian gravity enough for healthy human growth? NASA studies suggest partial gravity might not fully prevent bone and muscle loss. Mars settlers adopt rigorous exercise programs, and some base modules include spinning centrifuge pods to simulate higher gravity for a couple of hours a day. Radiation remains a wild card. A decade on Mars accumulates about 1 sievert of cosmic ray exposure, a serious dose. Yet many settlers choose to stay, forging on with the unwavering belief they're building a second home for humanity. In 2038, the colony adds a biodome, a spacious greenhouse sealed under a geodesic structure. Powered by solar arrays and nuclear backups, it grows vegetables, grains, and even a small fish farm. Colonists sit in a makeshift park inside the dome, breathing slightly humid air that smells of soil. It's a balm for their mental health. In a place with no Earth-like clouds, no oceans, and a pinkish sky, this green pocket of life is a reminder of home. And as more people come, a distinct Martian culture begins to form. Annual festivities on the date of the first landing, calls for democratic self-governance, and even talk of a unique Mars Council representing all inhabitants. By the late 2030s, Mars Base Alpha has grown into a small settlement of about 200 souls. A second outpost, New Dawn Oasis, is founded a few hundred kilometers away to tap rich mineral deposits. As supply missions from Earth continue, local leaders realize they need formal rules to manage property, resources, and disputes. In 2040, representatives from both settlements draft the Mars Settlement Charter, a compact that outlines local governance, resource sharing, and personal rights. These colonists look to the 1967 Outer Space Treaty, which designates celestial bodies as the province of all mankind, to ensure no single nation can own Mars. Instead, each settlement is akin to an international zone, somewhat like Antarctica, yet also developing its own identity. Tensions simmer between Earth-based mission control and the colonists' push for autonomy. Imagine a scenario. Earth administrators want to prioritize pure science, while colonists ask for more greenhouses to support mental health. Who decides? With communication delays of up to 20 minutes, the people on Mars feel they must have the final say. Slowly, a Mars Council evolves, an elected group that coordinates daily operations, mediates conflicts, and sets local priorities. By 2042, the population tops 300 across both major settlements. Martians, as they casually call themselves, rely heavily on Earth for advanced electronics, medicines, and specialized goods. But about 50% of their food and nearly all of their fuel for local operations now come from Mars itself. Each launch window brings new settlers, scientists, engineers, teachers, doctors, and even the occasional tourist who paid a fortune to experience life on the red planet. Within 20 years of the first landing, a rudimentary Martian economy is forming. NASA, ESA, and private ventures pay fees for research payloads to be tested on Mars. SpaceX offers passenger seats to wealthy adventurer tourists. There's talk of extracting rare minerals or setting up a propellant depot on Phobos, one of Mars's small moons, to refuel spacecraft heading deeper into the solar system. Economists on Earth debate whether Mars can ever become profitable. One NASA report estimates that a fully independent Mars colony might cost hundreds of billions of dollars. Yet others argue that knowledge gained from closed-loop life support and advanced 3D printing is already paying dividends back on Earth, making desert farming more efficient or allowing new building techniques in harsh climates. Also, intangible benefits are immense. Having a stable foothold on Mars is a testament to human collaboration. Former geopolitical rivals now cooperate on the Red Planet, forging commercial alliances in orbit. The Artemis Accords, once just about moon exploration, expand to cover Mars, creating a single framework for transparent, peaceful operations. By 2043, with repeated arrivals of new inhabitants, the combined Martian population approaches 400 or 500. Mars is no longer a distant concept. School children on Earth chat via video uplinks with classmates who happen to be Martian-born. The Mars generation effect, akin to the Apollo-era surge of enthusiasm for STEM, sweeps Earth once again. It's now 2050, 25 years after the earliest cargo missions began to arrive. What does our Martian colony look like? Life on Mars is still challenging, but the settlement has become more robust. Underground tunnels weave through pressurized chambers, housing workshops, medical wards, even a small school. On the surface, you see new biodomes shining under the sunlight, each a mini ecosystem for fruits, vegetables, and experimental cereals. The colonists supplement their diet with lab-grown proteins, cultured meat, because raising livestock is far too resource-intensive. In orbit, the newly completed Mars Orbital Station 1 receives each incoming Starship, where cargo and passengers transfer to specialized landers. On the surface, robotic mining operations produce water, ice, and metals, while heavier manufacturing emerges to create rocket parts. Scientists experiment with tiny terraforming trials, mirrors in orbit focusing sunlight onto the poles, or hardy algae introduced into controlled outdoor plots. These changes are small but do indicate the colony's eventual direction, turning Mars into a more habitable world, step by step. Yet ethical debates flare up on Earth. Planetary protection advocates worry about contaminating potential Martian microbes, especially if the colony expands into areas of subsurface ice. Others wonder if we have a moral duty to preserve Mars in its natural state, rather than reshaping it for our comfort. Meanwhile, most settlers argue that partial terraforming is vital for long-term survival, especially for children growing up under cosmic rays and low gravity. Another dilemma: should Mars remain politically tied to Earth? By now, the Martian Council essentially governs local affairs. Earth's Mars Accord might treat the colony as a neutral zone. No country can claim it, but the people there might eventually demand independence. For the moment, it's a delicate balance of Earth-based sponsorship and local autonomy. Through it all, there's a growing realization back on Earth. Despite the eye-watering expenses, the colony has driven a revolution in technology. Advanced recyclers, perfected on Mars, are solving water shortages in arid regions. Agricultural breakthroughs used in Martian greenhouses help famine-prone areas. The synergy is apparent. As humans learn to thrive on Mars, they also gain new tools to safeguard Earth. So what if we actually pulled it off? By 2050, humankind might be truly interplanetary. Perhaps 1,000 people call Mars home. Several of them were even born there, never having set foot on Earth. The idea of traveling between worlds, once purely the stuff of science fiction, becomes a matter of scheduling the next launch window. Would we start sending more diverse groups, artists, musicians, or philosophers? Might a brand new Martian culture arise, blending traditions from all over Earth, but adapted to a 24-hour and 40-minute sol? Could massive orbital mirrors and engineered microbes eventually create pockets of breathable air or stable lakes? Nobody can say for sure, Yet the seeds of all these possibilities lie in the technology, the funding, and the unwavering curiosity that took us from maybe someday to we're here in just a few decades. In the past, each great age of exploration reshaped earthly civilizations. This time, we're extending our horizons literally beyond our home planet. The colonists on Mars, these engineers, scientists, dreamers, and families are forging a new chapter in the human story. They remind us that we can dare mighty things, that collaboration beats conflict, and that no frontier is beyond our reach if we work toward it day by day, soul by soul. Who knows? Perhaps in 25 years you might hop on a starship yourself, wave goodbye to Earth, and step onto the red soil to begin your own Martian adventure. This has been our glimpse into a future where humanity colonizes Mars within the next quarter century, a future grounded in today's NASA plans, current private sector advances, and a dash of imagination. Whether or not every milestone happens right on schedule, the spirit of exploration and scientific innovation driving us forward remains very real. Thank you for journeying with us to the Red Planet. Wherever our species travels next, we'll carry our determination, our curiosity, and our hope for tomorrow. After all, Mars is waiting, and someday soon, we just might call it home. And before you go, we'd love to hear your voice. If you enjoyed this exploration of future possibilities, please hit that like button and share your thoughts below. What other what-if scenarios or frontiers fascinate you? Is it exploring the oceans of Europa, constructing orbital cities around Earth, or perhaps mining asteroids for resources? Let us know, and we may turn your suggestions into our next deep dive. Remember to subscribe for more thought-provoking journeys into the realms of science, speculation, and everything in between.